Hello my dear students! Welcome back to our YouTube channel. This is me again, Teacher Tin May. Kumusta kayo? Happy New Year sa inyong lahat! Of course, nandito na naman muli tayo para sa panibagong yugto ng ating science journey, ng ating science lesson vlog in Science 8. So kung nakatuto ka sa channel na ito, binabati kita ng isang malaki at masaganang congratulations! Dahil na-complete mo ang ating first quarter. At ngayon nga ay nasa second quarter na tayo at panibagong lesson na naman ang ating tatalakayin. Kung bago ka pa lang sa channel na ito, don't forget to subscribe, like, and hit the notification bell for more updates in Science 8. For today's lesson vlog, para sa ating week 1 ng ating Module 1 Science 8, we're going to discuss about earthquakes and fault. Okay, that is our first topic for this quarter. And of course, at the end of this activity, at the end of this lesson, okay, we will be using models and illustrations to explain how movements along faults generate earthquakes. Okay, so merong mga vocabulary term na kailangan nating intindihin at malaman na syempre related dito sa topic natin. Of course, we have the fault. We also have the earthquake. And last, we're going to discuss about the different types of stresses in the Earth's crust. Okay, samahan nyo ako hanggang dulo at himay-himayin natin ang mga topic na ito. But before we proceed with our discussion about earthquakes and fault and the different types of stresses in the Earth's crust, let us take time to read and watch the article about the earthquake that happens in Luzon, which is 5.3 magnitude quake that hits Luzon. 5.3 magnitude quake hits Luzon, Philippines. An earthquake with a magnitude of 5.3 jolted Luzon of the Philippines on Sunday morning, the U.S. Geological Survey said. The epicenter, with a depth of 86.86 km, was initially determined to be at 14.0476 degrees north latitude and 120.525 degrees east longitude. The three widely felt earthquakes shook the Philippines today, but it's unclear if they triggered each other. The earthquake, which struck at 3:18 a.m. local time on Sunday, was centered in the sea about 31 km 20 miles northeast of Lubang Island or 89 km 55 miles west of Calamba and 65 km 41 miles southwest of Balanga. The Philippine Institute of Volcanology and Seismology, or the PHIVOLCS, said the quake measured 5.5 and struck at a depth of 85 km or 53 miles, which is relatively deep. There is no threat of a tsunami, but aftershocks are likely, according to PHIVOLCS. Shaking from the earthquake was felt across the region, including in Manila and Quezon City, where some said the tremors were strong enough to wake them. There were no immediate reports of damage and casualties. The Philippines is on the so-called Pacific Ring of Fire, an arc of fault lines circling the Pacific Basin which are prone to frequent and large earthquakes. Volcanic eruptions also occur frequently in the region. It is said by the Philippine Daily Inquirer Asian News Network on May 16, 2020. These past few weeks and past few days, we heard a lot of news about the different earthquakes that happens in the Philippines. Kung saan saang bansa or kung saan saang lupalop dito sa Pilipinas nagkaroon ng naitala ang iba't ibang level or magnitude ng earthquake. Ano nga ba pag sinabi nating earthquake? Okay, when we say earthquake, this is caused by a sudden slip on a fault. Pag sinabi nating earthquake sa Tagalog, ito yung tinatawag natin na lindol. Paano ba nangyayari ang lindol? Pag sinabi nating lindol, ito yung pagyanig ng lupa dahil sa pagguho o pagdulas ng lupa sa ibabaw o ilalim ng lupa. Meron tayong dalawang uri ng earthquake. One is the tectonic earthquake and the other one is the volcanic earthquake. So when we say tectonic earthquake, this is caused by the movement of the crust plates. So kapag naman sinabi nating volcanic earthquake, ito naman yung dahilan sa pagsabog ng isang bulkan. Kaya ang earthquake, hindi natin yan napipredict. Hindi kagaya ng bagyo na andyan ang pag-asa para ipredict kung kailan darating ang bagyo, kung gaano kalakas yung parating na bagyo. Pero ang earthquake, hindi yan nadedetect. Kaya ito ang mahirap sa earthquake. Pero meron naman tayong tinatawag na hazard map. So sa hazard map, makikita natin dito yung mga fault line na makikita sa iba't ibang dako ng Pilipinas at ng iba't ibang lugar. So, di ba nga ang sabi kanina, earthquake is a sudden slip on a fault. So, ibig sabihin, delikado ang mga lugar kung saan merong tinatawag na fault line. Ano po ba pag sinabi nating fault line?
An earthquake is caused by a sudden slip on a fault. The tectonic plates are always slowly moving, but they get stuck at their edges due to friction. When the stress on the edge overcomes the friction, there is an earthquake that releases in the form of energy in waves that travel through the Earth's interior and crust that cause the shaking that we feel. Friction between the two sides of a fault keeps it from moving until the stress on the fault overcomes the friction. Then the fault slips and creates an earthquake.
What is fault? Fault is a fracture or zone of fractures between two blocks of rock. Faults allow the blocks to move relative to each other. This movement may occur rapidly in the form of an earthquake or may occur slowly in the form of the creep. Ngayon, ang tanong, gaano po ba kahaba ang isang fault line? Okay, pwede siyang maging few millimeters lang ang haba, pero pwede siyang umabot ng thousands of kilometer. Kaya kung natatandaan nyo yung balita noong nakaraang taon or noong isang taon tungkol sa The Big One, which is ito yung kinakatakutan na mangyari sa Metro Manila, na pwedeng magkaroon ng The Big One na aabot siya ng 7.2 magnitude. So, paano nila na-predict at paano nila na-predict yung mga lugar na pwedeng tamaan ng sinasabing The Big One? It is because of the fault line. Kanina, binanggit ko na hindi maaring ma-predict kung kailan mangyayari ang earthquake dahil wala naman tayong device na pwedeng gamitin kung kailan darating ang earthquake. Meron tayong device na tinatawag na seismograph. Pero yung seismograph, this is only a device that can detect the magnitude of the earthquake. Hindi kagaya nga ng bagyo na pwede nating i-predict kung kailan siya darating, kailan siya paalis, at gaano siya kalakas. So, paano nalaman itong mga lugar na pwedeng tamaan ang tinatawag na The Big One na meron daw 7.2 magnitude? Okay, so ito yung may tinatawag nga tayo na hazard map. So, sa hazard map, makikita natin yung mga fault line na pwedeng makita natin dun yung mga lugar na pwedeng tamaan kapag nagkaroon ng isang matinding earthquake. So, di ba ang sabi nga natin, earthquake occur, it is because nagkakaroon ng movement doon sa fault line. Yung fault line kasi, ito, yung fault na tinatawag natin, para siyang crack. Ano, di ba? Imagine nyo ang isang vase na meron na siyang crack. Di ba mas lalo siyang delikado na mabasag dahil nga hindi na siya buo. So, ganun din sa lupa. Kapag nagkaroon ng pagyanig, dito nagsisimula ito dahil nagkakaroon ng bungguan sa mga tectonic plates na nasa ilalim ng ating kalupaan. At ito ang pinagsisimulaan ng isang lindol. Another question. How do faults generate quakes? Isang napakagandang katanungan. Paano nga ba nagkakaroon ng earthquake dahil sa tinatawag nating mga fault? Remember that energy from the Earth's interior makes the ground move. Friction holds the rocks together. But once the friction is overcome, nagkakaroon na dyan ng movement from the ground and then suddenly the earthquake will occur. And always remember that earthquake occurs when there is a sudden slip on the fault. Paano po nangyayari yon? Again, Di ba pag sinabi nating fault, this is the fracture or zone of fracture between two blocks of rocks. So, imagine natin itong dalawang box na to. So, ito yung two blocks of rocks. Okay, ang sabi ay zone of fracture. So, ibig sabihin, meron na siyang crack sa gitna. Okay, so imagine nyo na itong, ay, nako, nalaglag. Okay, so, tingnan natin na itong gitnang to, baliktarin nga natin para mas okay, so itong nasa gitna, yan yung itong nasa gitna, yan yung pinaka fault line natin. Opo, nalaglag po. Okay, so pagtabihin natin silang dalawa. Okay, kung ang lupa ay ganyan, at for example, kung yung bahay nyo ay ang kinatitirikan ng bahay ninyo ay nasa gitna kayo ng isang fault line, so imagine natin na ito yung inyong bahay na nasa gitna ng fault line. Okay? And then, sa paligid ng bahay nyo ay meron kayong puno, syempre. Tapos, for example, ay na ito ang inyong kotse. O, ayan. Kunwari, imagine ninyo na ito ang kotse, ang bahay ninyo ng puno. Okay, and then suddenly, nagkaroon ng movement sa fault line. Earthquakes are caused when fault slips suddenly. Anong sabi kanina rin? Ang dahilan ng lindol ay ang pagyanig ng lupa or pagguho o pag-slide ng lupa. So, ano mangyayari dyan? Bakit gumagalaw din yung mga bagay sa ibabaw ng lupa once na nagkaroon ng sudden slip sa ating mga fault line? So, imagine nyo kung nagkaroon ng movement sa ating lupa. So, ayan. Di ba nagkaroon ng movement din at paggalaw doon? Eh, paano kung matagal pa yun? At ganyan ang nangyari. So, talagang guguho ang mga bagay na naandun sa ibabaw ng lupa. Kanina, binanggit natin that friction holds the rocks together. So, para hindi gumalaw yung mga lupa, may tinatawag tayong friction. And when we say friction, this is the force that opposes motion. Okay, so kung yung mga rocks ay may friction para hindi siya gumalaw, pero once na na-overcome na nila yung friction, ibig sabihin, hindi na kinaya ng friction, diyan nagsisimula na magkaroon ng paggalaw sa bawat lupa. Faults are classified according to the movement of two blocks. Now, let us identify the different types of faults. So, we have three types of faults. Number one, we have the normal fault. We also have the reverse fault. And number three is the strike-slip fault. Sa normal fault, ang sabi dito, it occurs when the hanging wall moves down relative to the foot wall. So, bigyan ko kayo ng example. So, kunwari ito yung ating two blocks of rocks. Ano po? Okay. So, ang sabi dyan, meron tayong tinatawag na foot wall. So, imagine natin na ito yung foot wall at ito naman yung hanging wall. It occurs when the hanging wall moves down relative to the foot wall. So, ang movement niyan is naghihiwalay sila. Yung lupa naghihiwalay. So, ang tendency niyan, bababa itong isang hanging wall. Again, ang sabi dyan, it occurs when the hanging wall moves down relative to the foot wall. So, yun yung nangyayari dyan sa lupa natin. So, nagkakaroon ng paggalaw, which is yung arrow niyan is, yung isa ay papunta dito, and then yung isa naman ay paganyan. So, kumbaga, palayo ang nangyayari sa kanila. Kung ito yung dalawa nating two blocks of rocks, paganon. Ano po? So, paghihiwalay nila, ang tendency nung lupa, yung hanging wall, bababa siya. So, pag ganun ang nangyayari sa kanya. So, ulitin natin. So, itong dalawa, and then, bababa siya ang paganyan.
Normal fault. A deep slip fault in which the block above the fault has moved downward relative to the block below. This type of faulting occurs in response to extension. Occurs when the hanging wall moves down relative to the foot wall.
Okay, number 2 is what we call the reverse fault. So, pag sinabi nating reverse fault, kabaliktaran naman ito nung tinatawag nating normal fault. Kung ang normal fault ay palayo, so ang tendency naman ng reverse fault is papunta siya sa isa't isa. So, ang direction niyan is magkasalubong. Okay, so for example, we have the foot wall and we have the hanging wall. So, it occurs when the hanging wall moves up or thrusts over the foot wall. So, since nagbubungguan yung dalawang blocks of rock, so pag nagbungguan sila, yung isang block of rock, which is the hanging wall, aakyat naman siya pataas. So, ang nangyayari dyan, papatong yung kabilang wall or yung kabilang block of rock doon naman sa kabila. Kaya nga ang sabi dito is, hanging wall moves up or thrust is over the footwall. So, ito yung footwall natin, ito yung hanging wall. So, pa ganyan. Ayan. So, gaganyan siya. Dahil nagbubungguan sila sa pagbubungguan nila. So, sa pag dito naman sa kamay, ang ginawa natin. So, since nagbubungguan sila kasi ang direction ay pa ganun. So, may isang tataas. So, footwall, hanging wall. So, pa ganun siya.
Reverse fault. A deep slip fault in which the upper block above the fault plane moves up and over the lower block. This type of faulting is common in areas of compression. When the deep angle is shallow, a reverse fault is often described as a thrust fault. Occurs where the hanging wall moves up or is thrust over the footwall.
And number 3, or the third type of fault, is what we call the strike-slip fault. So, ang tendency naman nito is nagkakaroon ng slide sa pagitan ng dalawang block of rocks. So, for example, ulit, na ito yung ating two blocks of rock. So, di ba kanina, ang tendency niyan is magkalayo sila at papunta sa isa't isa. So, dito naman, ang tendency niyan, for example, ito yung ating two blocks of rock. So, nag-i-slide naman siya. So, sa pagitan na natin sa kamay, so, paganto naman siya. Okay? And the best example of strike-slip fault is what we call the San Andreas fault.
Strike-slip fault, a fault on which the two blocks slide past one another.
Okay, there are two types of strike-slip fault. Number 1 is the left lateral strike-slip fault and the other one is the right lateral strike-slip fault. So, ano naman po yung pagkakaiba ng dalawang to? So, nagkaiba lang sila sa direction. Okay, pero ang tendency niyan, same pa din. So, kung ito yung dalawang two blocks of rock, so ito yung ating fault line, so ang tendency niyan is, it's either papunta doon or it's either paganto naman. So, paano natin malalaman if it is left lateral strike-slip fault or right lateral strike-slip fault? So, madali lang matatandaan yan. So, for example, ayan, nakaharap tayo dun sa fault line. Kapag nagkaroon ng paggalaw dun sa dalawang dupa, okay, kapag yung left, so ito yung left natin, and this is our right. So, kapag yung left, yung nakaturo sa'yo, ayan, nag-move na siya. So, pag yung left, yung nag-move papunta sa'yo, that is what we call the left lateral strike-slip fault. But if it is right lateral strike-slip fault, yung right naman, yung mag-move papunta sa'yo. So, that is the difference between the left lateral strike-slip fault and the right lateral strike-slip fault. And those are the different types of fault. Again, the normal fault, the reverse fault, and the strike-slip fault, or the right lateral and the left lateral strike-slip fault.
A left lateral strike-slip fault, if you were to stand on the fault and look along its length, this is a type of strike-slip fault where the left block moves toward you and the right block moves away. A right lateral strike-slip fault is when you were to stand on the fault and look along its length, this is a type of strike-slip fault where the right block moves toward you and the left block moves away.
Now, let us discuss about the different types of stresses in the Earth's crust. And you know that Earth has 3 layers. It composed of 3 layers, which are the crust, the mantle, and the core. So, yung crust, pwede natin siyang i-compare sa eggshell. Yung balat ng itlog na manipis lang. And that is can also symbolize the Earth's crust. At pag sinabi nating Earth's crust, this is the thinnest layer of the Earth. At di ba yung itlog, kapag binasag niya yan, naghiwa-hiwalay, pwede siyang magkakaiba ng sizes. At pwede natin itong ihalin tulad sa ating continental plate na magkakaiba rin ang kanilang sizes. Okay, now, ang nangyayari sa ating crust, kapag nagkaroon ng push and pull, in these continental plates, nagkakaroon ng stress. When the plates are push and pull together, stress occurs. And we have 4 different types of stress that affects the Earth's crust. Number 1, we have the compression stress. Next, we have the tension stress. We also have the shear stress. And number 4, we have the confining stress.
Compression stress. Compression is a type of stress that causes the rocks to push or squeeze against one another. It targets the center of the rock and can cause either horizontal or vertical orientation. In horizontal compression stress, the crust that can thicken or shorten. In vertical compression stress, the crust can thin out or break off. The force of compression can push rocks together or cause the edges of each plate colliding to rise. Mountains are a result of high-impact compression stress caused when two plates collided.
Okay, anong meron sa compression stress? Okay, from the word itself, compression, di ba pag sinabi natin compress, magdikit-dikit. Kaya nga pag magpipicture kayo, pag sabi, oh, compress, di ba ang tendency nyo is magdikit-dikit kayo. So, ganito rin yung nangyayari naman sa mga plates when the rocks, it causes the rocks to push or squeeze with each other. So, kapag nag-squeeze sila ng sabay-sabay, it causes the rocks to push or squeeze against one another. So, ang tendency niyan, for example, yung clay, kunwari, naglagay tayo ng clay dyan, tapos pinush mo ng pinush at in-squeeze. So, ang tendency niyan, pwedeng may kumapal, may lumiit. Okay, ito naman yung nagkakaroon tayo ng vertical or horizontal orientation. At ito ang nangyayari kung bakit meron tayong mga kabundukan. Kasi dahil yan sa compression stress na nagmo-move yung mga continental plate, nagbubungguan sila sa isa't isa. Kaya ang tendency pag nagbungguan sila, kumakapal yung nasa gitna. Kasi ang tinatarget nito is yung center ng rocks. Kaya may kumakapal. Now, let us talk about the tension stress. Okay, the tension stress, this is opposite naman to ng compression stress. Kung sa compression, nagkakaroon ng collision and pushing and squeezing of one plate with another. Dito naman sa stress, dito naman sa tension stress, kabaliktaran. So, ang tendency naman dito, yung mga plates ay they move farther away from each other. Kaya nga dito nga nagsimula yung kung bakit tayo nagkaroon ng iba't ibang continents. Kasi before, we have this term Pangaea, which is a supercontinent that existed during the Paleozoic and Mesozoic era. So, but because of the tension stress, the tendency of the tension forces, okay, yung rocks ay, they pull apart. They separate from one another. Kaya nagkaroon ng pagkakalayo-layo yung ating mga continental plates.
Tension stress. Tension is the opposite of compression. While compression forces the rocks and crust to collide and move together, tension forces the rocks to pull apart. Tension can happen in two ways. Two separate plates can move farther away from each other, or the ends of one plate can move in different directions.
Now, ano naman yung pangatlo, which is the shear stress? Okay, ang shear stress naman, it pushes the crust away in different directions. So, ang tendency naman niya is yung mga large part ng crust is kapag sila ay nag-move, so nabe-break siya into smaller pieces. Kaya yung mga malalaking sizes na mga crust, pwede siyang mag-turn into smaller sizes of plates. Okay, so usually nangyayari to kapag yung two blocks of rocks ay nag-collide and then nag-move siya in opposite direction. So, kaya lang dito sa shear stress, okay, yung tension o yung friction ng shear stress dun sa edges ng mga plates, ito yung pwedeng mag-cause ng earthquake.
Shear stress. When shear stress occurs, the force of the stress pushes some of the crust in different directions. When this happens, a large part of the crust can break off, which makes the plate size smaller. Shear stress usually happens when two plates rub against each other as they move in opposite directions. The friction of a shear stress at the edges of the plate can cause earthquakes.
And for the last type of stress, we have the confining stress. Paano ba nangyayari ang confining stress? Okay, sa confining stress, it only occurs kapag yung stress ay na-apply na sa lahat ng sides ng isang crust. Kung maaalala nyo, may mga balita sa TV or makikita nyo sa mga internet na may isang part ng earth crust na meron siyang butas sa ilalim. At palaisipan kung paano daw nagkaroon ng butas sa ilalim yon, bakit ang lalim ng hukay. Yun yung mga tinatawag natin na mga sinkholes. At gawa yun na tinatawag natin na confining stress. Yan yung dahilan kung bakit nagkakaroon ng sinkholes. Okay, paano po ba ito nangyayari?
When stress is applied to all sides of the crust, confining stress occurs. When this happens, the crust compacts, which makes it look smaller. If the stress is too much for the crust to handle, the crust can fracture from the inside. This causes the crust weight to decrease, but the crust shape remains the same. Because this type of stress can hollow out of the insides of the crust, confining stress can cause sinkholes in the earth.
This is the end of our lesson vlog in Science 8 for week 1. So I hope you learned something from me. Thank you for listening and watching this lesson vlog. This is me again, Teacher Tinmay. If you are new to my channel, don't forget to subscribe, like, and hit the notification bell for more updates. See you on my next vlog.